Hello everyone. Today we're going to talk about piecewise functions and how they relate to limits. So in Honors Algebra 2 we graphed piecewise functions by doing each individual point. Thankfully we don't have to do that. We just need to find it by direct substitution. Problem is what if we want where they connect? Then we determine the left and the right side limits. If they're the same, then the limit exists, and if they're different, the limit doesn't. Well, what do I mean? Well, here's a piecewise function that connects at the point 1. Any other point I would want, I could just plug in. But because it connects at the point 1, I need to figure out the limit here at 1 and the limit here at 1. So this says the limit at 1 minus. In other words, the left side. Well, this is the left side because it's less than 1. So I'm going to plug 1 in right here. So I got 1 over 2 plus 9 over 2. Well, that's 10 over 2, which is 5. So the left side limit is 5. Now let's find the right side limit. The right side limit is 1 plus, so I'm going to go on the right side. I'm going to plug 1 in right here. So I'm going to have 1 minus 6 plus 10, which is also 5. The left and the right side limits will always exist. The question is, does the limit exist? Not the left side or the right side, but the actual limit. In this case, yes. The left side and the right side both exist and are 5. Therefore, the answer is 5. So this is a pretty simple concept. Just see if the limit on each side matches. So let's take a look at this problem. This wants to know what's going on as you approach -2 from the left, -2 from the right, -2, and then the point at -2. So this is -2 from the left. Well, they connect at -2, so I need to check the left side of that, which is the less than side. -2 squared is 4. How about from the right side, -2 plus? -2 plus is here, it's the greater than the -2. I'm going to plug it in here. So if I plug in -2 right there, I'm going to get -2 over 2 plus 3. Those will cancel out. That'll give me 1 plus 3, which is 4. Hey, look, they're the same. The left side and the right side are the same, so the limit exists. Now, as for the point at -2, only one of these is the point at -2. Is it the top or the bottom? It's the top because that's where it's equal to -2. So I plug in -2 here and I get 4. That one's pretty easy too because the left side and the right side are the same. What about these? This one says as x approaches -5. Well, -5 isn't the point where they connect. It's just a point. Does it go in the top or the bottom? It goes in the top because -5 is less than -2. So just plug in the -5. -5 squared is 25. How about the limit at 0? Well, that's also pretty easy. 0 isn't the point it connects. 0 is bigger than -2, which is the point it connects. So I'm going to plug the 0 in right there. 0 divided by 2 is 0, plus 3 is 3. So, don't always assume that I'm going to ask you the question about where they connect. I could also ask you what happens in the space on either side.